Hey everyone, welcome back to the SDL2 with C. So for this log, we're taking our animation system to the next level. So by adding direction-based movement and turning our simple code into a modular, reusable animation system. So the last time we handled the basic animation, but everything was tied directly into game struct. That worked fine, but as we added enemies, NPCs, and more complex movement, we need something cleaner and scalable. So today we separate the animation logic into its own system, given us a mini engine that handles animation updates, direction changes, and rendering independently from the rest of the game. We also implement directional animation so our character or player can walk up, down, left, and right using a single sprite sheet with multiple rows. By the end of the slog, you'll have a polished movement system where your player smoothly animates in all directions, and the animation logic can easily be reused for any character in your future projects. So let's dive in and build it step by step. For the project structure, we have cmakelist.txt, include folder, sr or src folder, asset folder. Inside the include folder, we have the animation.h and game.h. Inside the src folder, we have the animation.c, game.c, and main.c. For the assets folder, we have the character.png. Now for the cmakelist.txt file, so this cmake will generate the executable file and responsible for linking the libraries that we needed. And cmake is our build system as well. So inside the animation header file, we will going to have the enum called direction. So this enum defines direction. We'll use then to select the right animation row in the sprite sheet. And then for line 21 up to 32, we have an animation struct. So each animated character or object will have an animation struct. So in line 35 up to 39, we have our function prototypes. So inside the animation.c file, in line 9 up to 21, we have our animation create, or it will take the texture and sprite sheet details or properties. So we will going to have, or we will going to allocate a memory called a animate, and then we will going to allocate that memory inside the heap. Now in line 28 up to 38, so we will going to have an animation update. So uses a delta time since last frame for smooth animation. So when moving is true, it will cycle through frames. So when idle or not moving, it shows frame 0, or it will going to set the frame to 0. Now in line 45 up to 58, we will going to have an animation set direction function. So it means that which row of the sprite sheet to use, whether the character is moving or standing still. So in line 56 up to 65, we have an animation renderer. So this renderer responsible for creating a source rectangle. So this source rectangle is the chosen base on the current frame and the current direction. Then it copies the region from the texture onto the character or the player destination rectangle on the screen. So in line 70 up to 72, we're going to pre-up the resources that we use. So that's why we have the animation destroy function. So inside the game header file or game.h, in line 13 up to 22, we have a game struct. So this will hold the SDL windows and renderer, and also the character animation objects, position, and movement. So in line 25 up to 29, we have our function prototype. Now in line 6 up to 28, we will going to initialize the SDL image to accept the PNG and also the creation of window and renderer. In the line 42 up to 46, we will going to have a creation of texture and loading the image. So you can actually load a sprite sheet using the surface, and then you are going to create a texture from that surface. So here we use the image load texture, so to create a texture directly from the asset that we have. And now from line 49 up to 53, we have, or we set our animation or character animate. So we're going to create the animation, or we're going to create an animation out of that texture. Now in line 55 up to 56, we're going to set the speed, and we will going to set the game running to true. Now in line 60 up to 72, we have the game handling event function. So we will going to have an event loop, and then we will going to have we're going to get the keyboard state, and then we're going to track both direction and the movement state as well. Now in line 77 up to 96, when the arrow keys are pressed, we're going to change the character or the player position and change the direction and mark moving to true. So in line 99, this will sync the animation state with movement state. In line 106 up to 108, we have a game update function. So here it will update the frame timing and the rendering of the sprite that we have. In line 111 up to 118, so we have a game renderer. So in line 120 up to 128, we are going to clean up the resources that we used. So inside the main.c file, we are going to initialize the game, and then we will going to have our main loop. So inside the main loop, we're going to measure the lapse time per frame, and then passes the delta time to animation system. And then we're going to keep a stable 60 FPS or frame per second, which is the frame rate. And then we're going to clean up the game once we exit from the loop or from the game. Now we're going to build our project using the CMake, and then CMake will generate the executable file, and we're going to run that executable file. And that's it for our improvement of our project. We successfully built a modular animation system that supposes direction-based movement and uses delta time for smooth frame control and resets to idle when not moving. In the next log, we'll take this further by adding the collision detection and basic enemy movement so your character can start interacting with the world in a meaningful way. If you found this helpful, don't forget to like and subscribe, and thanks for watching, and I'll see you in the next one.